this video, I'm going to be connecting the traditional algorithm for dividing decimals with the model. So the first thing I would do in my model is I would represent my decimal. So I have 5 and 372 thousandths. I'm going to represent 5 in my ones place, 3 in my tenths, 7 in my hundredths, and 2 in the thousandths place. So now at this point, I want to divide my 5 and 372 thousandths into 2 equal groups. And so right here, I've got one group and then a second group. Actually, let me just make this a solid line to show that this is the distinction between one group and two groups. And I just have it done this way so that I know which of the little circles I draw represent which place value, and it's just easier like this. So I'm going to start with my largest place value, the 5 in the ones place. On my traditional algorithm, I've got my 5 in my ones place. So I'm going to divide out my 5 ones into 2 equal groups. And I'm not going to go one by one because I've got better math sense than that, and I know that 2 groups of 2 will get me close to 5. So I'm going to do my 2 groups here, 2 groups here. So what I ended up having is I ended up having 2 in each group. I used 4 of my ones, which leaves me with 1 left over, as well as my 3/10, my 700ths, and my 2,000ths. So now at this point I have 1 and 372 thousandths remaining. I'm still going to focus on my ones place. I have 1 left, which will not split equally between these 2 groups as a 1. So I'm going to regroup it as tenths, and there are 10 tenths. So 1, 2, 3, 4, 5. I think I did that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Okay, so now I have 13 tenths, which we can also see on the traditional algorithm. I have 1 and 3/10 here. So when a lot of times people ignore the decimal and say, oh, how many times can go into 13? Well, it's not 13 whole. It represents 13 tenths, which we can see right here, and we can see in the model. So now I can divvy out my 13 tenths, and I know that I can have 6 in each group. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I have 1 remaining. So I have 6 in each group. I have 6/10 in each group. I used a total of 12 tenths. So what I have remaining is I have 1/10, as well as I have not used any of my 700ths yet, or my 2,000ths. All right, so now I'm going to work my way over. I still have 1/10 left, but it will not split equally between 2 groups. So I'm going to decompose it and regroup it as hundredths. Okay, so now I have 1700ths, which we can see right here. I have 1700ths. I want to divide those out into 2 equal groups, and I know I will have 8 in each group. Oh, I need to do that step here. Sorry about that. No, I already did that step. Okay. So I would use 8 in each group. 1, 2, 3, 4, 5. 1, 2, 3. And 1, 2, 3, 4, 5. 1, 2, 3. Okay, so I have now, there are 8 hundredths in each group. I used 16 of my hundredths, and I have 1/100th remaining. So in the traditional algorithm, we can see that when we subtract here, we have 1/100th remaining, and still my 2,000ths. So at this point, hopefully you're seeing the pattern here. I have 1/100th remaining, which will not split between the 2 groups, so I'm going to decompose it and regroup it as thousandths. Okay, so I have 12 thousandths. I have 12 thousandths. I already know that that's going to split into 6 and 6. So I have 6 thousandths in each group. 6 times 2 is 12. And that is exactly what I passed out, is I passed out 12 thousandths. Okay, so now I have divided all of my 5 and 372 thousandths. My answer is in one of the groups. It is also at the top of my standard algorithm. So I have 2 ones, 6 tenths, 8 hundredths, 6 thousandths. So my answer to 5 and 372 thousandths divided by 2 is 2 and 686 thousandths. Right there.